right, this is section 1.4, combinations of functions. So the first thing we're going to do is just practice plugging stuff into functions using our function notation. So these both involve multiplication, but the multiplication on each one is a little different because one of them, the 2 is multiplying through the finished, like the entire function, and the other one we're plugging the 2 in with the x's. So then it changes them a little bit. So f of 2x means that we're plugging a 2x in everywhere we have an x. Oh, I left out the 3. So we get negative, and then we have 2 times 2 is 4, and then we have x times x is x squared, and then we have 3 times 2 is 6, and then we have 4. So that's what happens when we plug in a 2x in place of the x's. Now let's see if we just do 2f of x, how that looks different. So 2f of x would mean we're multiplying our entire function by 2. Which gives us negative 2x squared plus 6x plus 8. Are those functions the same? No, so f of 2x is a different function than 2f of x. So it's very important to know how to plug stuff into functions when you're working with them. There are some similarities, but they're definitely different. Okay, now let's work through this next group of problems and see how they are similar and different. We've got adding 2's on the inside, adding 2 on the outside, taking f of x and just adding f of 2. The purpose of these examples is to show that where the 2 is located in the problem makes all the difference, right? It changes how you do it. So this one, f of x plus 2, means we are plugging x plus 2 in everywhere that we have an x. And then we simplify it. So don't forget, the x plus 2 squared isn't just x squared plus 4. X plus 2 squared is x times x, and x times 2, and x times 2, and 2 times 2, all added together. Some teachers refer to that as FOIL, where you multiply first, outside, inside, last. It's really just the distributive property where everything is multiplying times everything else. So that would give us x squared plus 4x plus 4. Any questions on that part, where I multiply it out, distribute it, and do a little like side note thinking bubble if that helps. So x plus 2 squared means we're doing x plus 2 times x plus 2, which gives us x squared plus 2x plus 2x plus 4. And that's where this came from. Yeah? Cool. Okay, so then, just a little thought bubble. So I'm just thinking through it. Then we're just going to go ahead and multiply out our 3x, and our 3 times 2 is 6, and now we have a 4 at the end, and I forgot to write the x down. Okay, that negative needs to go through this. Could maybe combine steps. I'm always afraid when I combine steps that I'm going to miss. So I'm just going to write it out again. It takes more space for writing, but then I don't make mistakes. So then I have negative x squared, I have a negative 4x and a positive 3x that I can put together. So that gives me negative x. And then I have a negative 4, a positive 6, and a positive 4 I can put together, which leaves me with a positive 6. So altogether, we end up with this answer here. That was probably the most difficult one to do, just because of the foiling process. Do you want me to give you a second to kind of process that? Since we're still writing. Maybe just make sure you understand what happened. How are we feeling about it? Maybe a thumbs up, thumbs down type of indicator on this would be good. Remember, you're getting this okay. And Remind me your name. Gee. Okay, should I move on? I don't know if I gave you enough space. F of x plus 2. That literally just means we're going to take f of x, which is negative x squared plus 3x plus 4, and we're going to add 2 to it. Ta-da! So our 4 at the end turns into a 6, and everything else stays the same. Compare that process to the one we just went through. Yeah. Putting that 2 in a different place. Putting that 2 in a different place changed the problem entirely. Okay.
Let's try to have more of those. Don't like the other.
Aw, got it. You can do it.
I know I can't do it.
You just don't want to.
Yeah.
Okay, got it. F of x plus f of 2 means we're going to take f of x, which is negative x squared plus 3x plus 4. And then we're going to add to that, I'm going to change colors just to differentiate it, f of 2. So f of 2 would be negative 2 squared plus 3 times 2 plus 4. So let's work that through. So 2 squared is 4, and 3 times 2 is 6, and 4 times, or yeah, it's just a 4. So that's just going to be a 6. So now we're going to combine this and this together because those cancel out. And we end up with negative x squared plus 3x plus 10. So you can see in all of these problems, example part 1 and part 2, every single question has an extra 2 in it somewhere. And depending on where that 2 is, we get an entirely different answer. So you have to be careful to follow the instructions according to that function notation. Alright. Moving onward. I feel like I might have skipped the page with the function arithmetic stuff already. Well, I think it's just because it's pretty simple. Maybe I have to put something else now. Gosh, this video is going to be fun. All over the place. Do I have it somewhere? Oh, look! It was just in the wrong place. There it is. Okay. Writing this out just feels busy anyway. It's okay. It's pretty obvious stuff. So if you're adding 2 different functions together, so part of the reason we use function notation sometimes is so that we have to name functions different things. So like, if we have 2 different functions named f of g and we want to add those functions together, we're literally just adding the functions together. But these are different. This is one way of writing that. That's another way of writing it. The whole point of this page is understanding that these notations mean the same thing. So subtraction can be combined into one parenthesis or it can be separated out. Multiplication can be written all in one or it can be separated into 2 separate functions. Division can be written all in one division problem like this, or it can be separated into 2 division problems. Anytime we have division, we also always have to have a disclaimer that we can't divide by 0. So that's the point of that, is just disclaimer, can't divide by 0, and it's good. So I'll give you a minute to look at that stuff while I stop the video so